Hello and welcome to our webinar. First of all, just some very brief introductions. I'm Andy from BCP Software. So we're a business solutions company, been specialising in warehouse management systems for over 40 years now. My background has been working in the business system space for over 25 years. Mainly with a focus on businesses exploiting technology, particularly for clients in the B2B and B2C distribution space. If you'd like to get in touch, my contact details are shown on the slide. I'd be really interested in any feedback, or if you'd like to discuss anything or have any questions, I'd be delighted to hear from you. So there's been various forms of automation available in warehouses for many years now, usually exploited in large, high volume businesses where the considerable investment that used to be required did deliver benefits through automated conveyor systems and sortation systems and things of that nature. In more recent years, without drawing too many parallels to the Terminator franchise, there's been somewhat of a rise of the machines, with warehouse robotics developing quickly, with a lot more types of robots, a whole variety increasing, and the technology evolving, and quite importantly, the costs actually reducing. So this is enabling the development of a wider range of applications of robotics and automations, and also making it more accessible for more modest size of businesses. So over the next 10 minutes or so, I'd like to share some thoughts on the implications of this and the considerations of using these technologies, and in particular their interaction with other processes that go on in warehouses, and also the technology that you will find in those places. So when we look at the range of robots available, or automation available today, we can see there's been an exponential increase in the number of suppliers, styles and options available. Robotics today come in a variety of shapes and sizes. So if you look at a few examples of just to illustrate that for you. So we have from relatively simple storage carousels. These are very good at storing high volumes of relatively small parts in a very confined space. We have collaboration robots. So as the name suggests, these robots work with warehouse team within either what we call a follow me mode or a meet me arrangement. Follow me is where the robots will follow a person around, for instance, a picking area, allowing the person to pick items and place it into a picking tote that the robot is carrying around. The main benefit of this, of course, is that the human can focus on the task in hand and doing what humans are best, while the robots will fetch and carry the totes and the completed totes back to a marshalling area, saving the warehouse person the time and energy associated with doing that. A meet me process is very similar. However, this uses multiple robots which will visit a particular warehouse area and invite the warehouse operator to pick items into multiple totes carried by multiple warehouse, but working in a very similar way. So collaborative robots are designed to reduce unproductive time, with the robots doing the fetching and carrying. Other variants include tugger automated guided vehicles. So this applies the same technique, but will transport or tug, as the name suggests, a traditional kind of picking cage instead of small totes around it. So therefore, utilising very similar hardware that might be available in your warehouse today. We then have goods to person robotics. So this is where the robot will actually deliver items to a human who is in a static location from high density storage. So configurations of this include mobile racks, where a full rack of products is brought from the warehousing storage, physically to the operator who's at a fixed location where the operator can pick products from it. Or we have roaming shuttles which can deliver individual totes from a very high density area of warehousing. When we talk about these exciting technologies, we do have to talk about the systems, software and technologies that are used to drive them. Within a typical business, as well as the software needed to operate the robotics or other automated systems, there will be a number of other core systems that the business uses. So, for example, systems to run finance and sales and purchasing and supply chain and those kind of aspects. So if we're considering robotics or automation deployments, we must also consider how these interact and relate to these other core business systems. So let's take a quick look at what systems are typically involved in this kind of architecture. So at the core, we usually have an ERP or an enterprise resource planning system. This is usually at the heart of the business and controls business-wide processes, from managing the core data, such as product records, customers, suppliers, etc., to managing activities such as sales order processing, purchasing, and financial accounting. In terms of warehousing, it is typical for an ERP system to provide a relatively limited level of functionality to support warehousing processes. This might be appropriate for more modest operations, but due to limitations, businesses with significant warehouse operations benefit from greater levels of sophistication and automation that can be delivered by a specialist warehouse management system. The WMS or warehouse management systems are specialist systems that focus on warehouse operations, as the name suggests. So the WMS will know the warehouse map, its areas, its locations, its labour availability, etc. It will maintain details of where each individual piece of stock is, and then determine the various movements of stock to achieve the company's operational objectives and to meet customer demand. As stock is received, the WMS will determine where to put it, and as picking operations are ongoing, the WMS will determine the best movements and the best way to perform that pick by the operators. The next layer involved is focused on the execution of the tasks that the WMS creates. So if we put robotics aside for a moment and think about a warehouse operative, they may obtain instructions via a number of methods, from paper through to handheld terminals, mobile computing, even through to voice directive technologies, using a handheld, a wrist-mounted device or a headset. So the WES, or Warehouse Execution System, is responsible for distributing the tasks generated by the WMS to the appropriate user through the appropriate channel. Now, some WMS systems do also include WES as an integrated solution, but sometimes a separate WMS needs to be included. When we bring robotics into the picture, a further system known as Robotics Execution System, or WES, is needed. The WES is a software that controls the physical movements of the robots, distributing tasks to the appropriate unit, deriving the most effective journey, and then navigating this. So WES tends to be hardware specific. When we bring robotics into the picture, a further system known as a Robotics Execution System, or RES, is required. So this is a system that controls the physical operation and movement of the robots. So distributing tasks out to the appropriate unit, working out the best navigation, executing that navigation, and interacting with the various sensory and other ancillary items mounted on the device. So RES tends to be hardware specific. So where we have several different robot types, we also have to think about multiple systems and also consider the systems used to manage the more non-automated processes in the same warehouse. Robots have many great applications, and as the variety of robots increase and the costs reduce, the opportunities for more modest warehousing operations to adopt robots increases. However, we find that robots are only suited for certain tasks, and certain robot types are suited to particular tasks. This means that you may have different robots employed in different warehouse areas, and importantly, a blend of robotics and human-driven activities within the same business. An example of this would be where Follow Me robots or Tug AGVs are used to support the picking activity, while traditional forklift trucks are used for the put away and replenishment kind of activities. You may also find carousels in there because you may be using those to pick smaller items. So this requires the integration of human and robotic processes, as well as potential multiple robotics and/or automated systems, which can make things quite complicated. Flexibility is also desirable. As businesses change and new technology comes along, organisations need to be free to evolve quickly and cost effectively. So in order to support such a blending model, the layered solution architecture we've discussed works well, allowing elements to be plugged in as required. So here we have the ERP system, which remains at the core, this being integrated into the warehouse management system. The warehouse execution system is fed from the WMS and distributes tasks to the appropriate executing resources. So this may be a warehouse picking team member in a particular area of the warehouse using voice, or a put away instruction delivered to a forklift driver on a forklift mounted computer screen. The warehouse execution system can also feed the robotics execution system with tasks suited to the particular robot types. For example, sending the pick task to the Follow Me picking robots, or other picking tasks to the carousels, for example. This allows a flexible blend of warehouse operations and the ability to add in or change execution methods as the business develops. I hope you found this brief presentation useful. I'd be really interested in any feedback you have, or to discuss any aspects of this further, or if you have any questions or challenges you'd like to discuss, then we'd be delighted to hear from you. My contact details are found on the slide, and finally, thank you very much for listening, and I hope you enjoyed it. Thank you.